Hello everyone and welcome to this session for the .NET Fwdays 2020 online edition. My name is Alex Thissen. I'll be with you for the next 45 minutes or so, and we will be discussing the health checks facilities that have been created for .NET Core solutions. Now, for those of you who've been working on modern, maybe cloud-based distributed systems, you may have found that it becomes quite challenging to keep the entire system running because it's comprised of so many small and individual pieces that it's kind of hard to determine what the state of the entire system is, if it's still running smoothly or if it's struggling, and to find out when you need to intervene and take some countermeasures because things are not going so well. But you can only do that if you know the individual status and the health of the small services that make up the entire system. Now, traditionally, there have been a lot of ways to do this. Most often, information would be collected from the individual services by scraping the logs, getting trace information, the metrics from the systems, and collect that over the entire landscape in a centralized place, which is quite common in microservices, where there's a lot of small pieces. And there's a whole bunch of products out there, and I've listed a few, that give you the ability to gather all that information and make educated guesses about the health of your entire system. But this way of doing it, it's kind of like the way doctors and traditional medicine would work. Now imagine this chat conversation where you as a person would ask the doctor, "Doctor, am I sick?" And the doctor would say, "Okay, let's look at your metrics. And we see that you have a pulse of 60 and a blood pressure that's, well, it looks kind of okay. So you seem to be healthy." And in this case, the doctor is making this judgment based on the information that he gets from you as a person. And you would say, "Okay, thanks, doctor." And alternatively, if you would run into these metrics, where the doctor would see, "Oh, wow, you have a pulse of 180 per minute. Your blood pressure is really high. You must be sick because this is not normal." And you would say, "Okay, thanks. Now at least I know that I'm not doing so well." What you see here is that in this information, centralizing this information, namely the doctor who needs to know about all of his patients, get the metrics and make the judgments, it's quite challenging to get that information at all, because it's usually metrics that can be measured from the outside or are given and are pretty standard. I mean, pulse and blood pressure is not that indicative of your health. And it differs from person to person what this actually means. Now, if this single doctor should know it all, that he has to have very detailed and intimate knowledge of each of his patients. So in your system, you would have to know in a centralized place the specific behavior of all of your services. Now, a more modern way to do this would be that the doctor would be asking you. So it's the other way around. You wouldn't ask if you are doing okay, but the doctor would be asking you. And you would do this assessment for yourself. So you would say, "I have a pulse of 180 and a blood pressure that's pretty high." The doctor might say, "That doesn't sound good, but you could do the same." But it might just be that you're saying, "Oh, okay, this is kind of normal because I'm working out and the blood pressure might be higher and a higher pulse, but that's to be expected because I'm kind of busy right now." And other things that are internal to me as a person, I would say, "Okay, my back doesn't hurt." And that's usually an indication if I'm not feeling well, my back starts hurting, and it doesn't. So I seem to be healthy, even though the metrics might indicate otherwise for different persons. And the doctor would say, "Okay, you've made your own assessment, and that's kind of good." So the self-assessment is a more modern way, and this is what we will be talking about, your services that you build in .NET Core, how they can provide their own health information, because they know best. They know exactly how they function internally and what is an indication of the health not being good or being good depending on circumstances, and even some values that cannot be measured and cannot be put into numbers. Because you, as a developer of one of those services, know best how to indicate your health. So summarizing, and also pointing out the difference between metrics where you send out this information as a stream to something that is monitoring, like you would be sending the vital signs to your doctor. That's one way of doing it. And the health is determined on the outside, not inside of your application. And what we start looking at is what if your application knows about this information? So the monitoring system would query your application and ask to send the health information, because you can send that yourself. And this is very good for a DevOps mindset, because it means that the logic to determine the health is part of your application, and it's actually deployed together with your application code. And you don't have to ask another team to implement new queries or new rules inside of the monitoring tooling that indicate and make judgment calls on your health. Once you get started with this, you might want to start out simple. The simplest things would be availability. If an endpoint on your application is queried and asked for give me health information, and it gives a response, then it's available, and that's a good first indication that you're being alive at all. It could send out different status codes, and it could be formalized endpoints, so specific endpoints. You don't have to visit the homepage, for example. You can go to a special endpoint, for example, a relative endpoint called /health, and that would give you the information. It could be the time to respond, could be also telling something about whether you're struggling or are being healthy. And it could also be based on some internals where you monitor disk space or memory to make some statement about your health. Once you have that in place, or if you want to go a bit more advanced, you can start looking at what your service needs in dependencies from the outside. So that might be that if you have a web application that is querying some web APIs or is dependent on a content delivery network, if those are available, the application itself can say that it's healthy. Same goes for if it needs to reach out to databases, to service bus or other queuing systems, maybe storage. If all those are available, then it's healthy. If one of those is not available, your service could indicate I'm not healthy at the moment, because one of the things that I depend on is not there. We'll also talk a bit about readiness and liveliness. And those are pretty useful if you start doing container technology and start cooperating together with container orchestrators. And then finally, even beyond the advanced scenarios, you might start predicting what is going to happen based on some internals inside of your application. So if some trends in memory usage go up, you might start predicting that you might be unhealthy in the future. And that's why there's actually three statuses. There's not just the healthy status and the unhealthy. Healthy meaning 200 okay, this is fine, and the unhealthy giving a 503. But there's something in between that could be an indication that you are okay for now, struggling, might become unhealthy in the future. So that could make you look at things before they actually go wrong. One of the scenarios would be you see that your certificates that you're using for SSL traffic have an expiry date that will expire in about 7 days or so. And then you could say, okay, in about 7 days, I will become unhealthy. So this is not as good as I am because I have the certificate going still. And you might replace the certificate before it actually becomes unhealthy. Now, to get these checks inside of your application, I've been referring to it as services, but it can be any .NET Core application. Since .NET Core 2.2, all .NET Core applications have had the means to integrate health checks. And the health checks are available in NuGet packages. There's the core package, there's some extractions, and there's one in combination with the entity framework, and those give you the ability to perform health checks at all. If you want to expose them, then you would need the ASP.NET Core Diagnostics Health Checks NuGet package, because then you can actually reach that information from an HTTP endpoint using the .NET Core, ASP.NET Core framework. And this is how that will work. Imagine that you have an ASP.NET Core application, you have the implementation code in light blue, and you have your middleware that's exposing endpoints. For example, for a web API, it could be API and then some version and some specific endpoints. If you make this call to services at health checks, and you would need a reference to the health checks NuGet package, what would happen underneath the covers is that there's a dependency registered for the default health check service. And the next thing is that with the ASP.NET Core health checks middleware, you would be able to route incoming traffic from a endpoint of your choice, /health, for example. You could map that onto the default health check service. And that will perform all the health checks and send out the health status, being healthy, unhealthy, or degraded. Each of those health checks that's being performed is actually an implementation of the iHealthCheck interface. It's an asynchronous implementation that is required, where you are given a health check context that gives a lot of information about how you should determine your health check. And it will be, your implementation will be called whenever there's a need to perform a health check. So that can be on demand because somebody called into the endpoint, or it can be done through publishers, which we'll talk about in a bit. How is this done? Well, you would have one or more of those health check implementations. You would register those. And whenever there's a need to determine the health status, each of those health checks is being done. And as soon as one of those failed, then it's game over. This is actually from the GitHub source code, the Microsoft code. It made me think of the Aliens movie, where they are actually, this is a quote from that movie, it might be, I'm not sure. But it's kind of like if one of them fails, then the health status will be determined as unhealthy. So only one has to fail. So let's have another look again, how that works in a bit more detail. So if you have those health checks, we're back to the point where we add health checks and we have the default health check service registered. We also have the middleware endpoint registered. That's like this, so we need to do that. But then afterwards, we will add one or more of those checks. And we can add them with Lambda expressions, synchronous or asynchronous. We can have typed health checks with the actual implementation of the iHealthCheck interface. And you can have more of those checking various dependencies, for example. Now, once there's a call on this endpoint, an HTTP GET for /health, the middleware will route it. The default health check service will start building this health report. And it's actually an object called health report. It assumes that we're doing okay. So the green indicates that we're healthy for now, but now we'll start performing the health checks. So we'll do them all. And so it will execute each of the Lambda expressions, seeing what the health check result would be. As long as they are still green, the report will get different entries for each of the health checks with the status. Now let's assume that the SQL database call is too slow. And too slow for you would mean that it's actually degraded. So this is a health check in itself that is degraded. And the health report will also indicate that. So we will always take the worst result out of all the health checks. And if you have an external dependency, it could be a web API or a content delivery network that you're checking. If that is unreachable or doesn't reply fast enough, then your health check would also indicate that it's as a status of failed. And the health report indicates unhealthy as a whole. And you would get back a 503 with details of why that has happened, or maybe without details. That's up to you if you want to expose those details or not. This is what will happen if we do all of those checks. Now let's see that in action. So I'll switch to Visual Studio. And what I have here is a web API for .NET Core 3.1. It's a web API. It has a buggy controller. So it's the default controller with the values, but there's some bugs in there. And one of the things that is in the startup is that we actually do register the dependency injection registries for the health checks. We'll get back to the publishers a bit later, but this is where you see that there's 4 health checks being performed of various types. And if you want to go through the code, all of these health checks are listed here in the demo code, and the link to that will be shared afterwards. So you can look at all of these things at your own pace. But these are the 4 health checks that are there, and we also have this add health checks UI, which I will show a bit later. And then finally, you need to register the health checks endpoints. Well, the old-fashioned way would be use health checks, but the newer one would be that you would use endpoints, saying that you would map health checks to a particular endpoint, and there's actually 2 of them. The second one executes all of the health checks. The first one, the ping, only returns if it's available, and it doesn't perform any health checks at all. So 2 endpoints, ping and health, and let's see if we fire this up, what will happen for the implementation. So this is getting ready to start up now. There we go. It uses a bit of entity framework to push out some information, but now we're actually running, and the API is here. Now I could go to the ping endpoint, and the ping endpoint will just say I'm healthy or unhealthy, and it gives a 200 status code or the 503 if it's unhealthy. So this is what will happen if you just go here, and it will usually, well, it will mostly indicate healthy because there's no health checks involved. If you go for health, then you get the result of all of these things. And this is not the default behavior. The fact that we have pretty detailed information for each of those 4 health checks is done by a bit of extra implementation. And you might have noticed that there's a response writer here that says, write a health check UI response. We'll get to that in the next couple of slides. But these are the basics of doing the health check. Now you can actually, in this thing, if you go to API/buggy and add a number afterwards, it will start making it less healthy. So if we go back again and go here, and we go to the /health, you will actually see that this one, the tripwire, has become degraded, and the circuit breaker has become degraded because of the buggy implementation. And if we run this again and ask for the health status again, you can see that this one has gone unhealthy while this is still degraded, and the other 2 health checks are healthy, but the overall status has become unhealthy because of this one. So we can see that the endpoints are working. Well, we can take this a step further. So let's go here and take it a bit more advanced. Because we saw that there's a couple of health checks, and those were built by yourself, and you can do that. Out of the box, you will only get 1 health check, and that health check is provided by the package for Entity Framework. It ties into DB context, and it will check through the DB context and the connection information behind it if the database is available. You could build your own, as we've seen, but you could also leverage the Xabril libraries that are on GitHub and on NuGet, all open source, and they have an implementation for many health checks, varying from internals of your host machine system and network stuff, but also for most of the cloud services that are out there, Azure Storage, for example, but also AWS DynamoDB, various other types of database systems like SQL Server or MySQL, and there's many more coming along the way. So don't build them yourself, use what's there. This is a very good library, and you could even contribute your own. Now, there's some other things. We've already seen that you can register multiple of those endpoints. We did the ping and the health endpoint that were being mapped. But you can also do middleware options, like we saw, where we are changing the response that is given. And we've changed that to be very detailed information with the status per health check. And that's also from the Xabril library, so that they give you this extra detailed information. Just add that delegate to the rewriting of the response, and you should be fine. I'll talk a bit about the health check registration in the dependency injection system while we go through some code again. But as you may have seen, looking at the JSON files and pinpointing where it might have gone unhealthy is pretty well, cumbersome and not so easy during development. The Xabril library also has this health checks UI package that you can use, and you can host that from your core application itself, or you can host it outside of your application or web API to avoid deploying this into production as well, but still being able to see all of this. And it will visualize the results of the health check endpoints. So let's see how that all comes together. So we had the map health checks UI that was there in the endpoints. This, together with the registration of the add health checks UI, will get you the health check user interface. And it looks kind of nice. If we go there, we can do localhost 5003 health checks UI, and we can actually see that our current status is the one we saw, that there's a degraded thing and an unhealthy thing. This updates by itself every 5 seconds. It will do that. So if you would restart it, it would start out all green. But this is much nicer to look at from your machine and see if you push it into a certain state, that the health checks indicate that it's being degraded or in an unhealthy state. So you can make this part of your testing of your implementation as well. There's many more things that come into play. For example, and go through this. If you look at the source code from the Git repository, but there's actually a way to register all of these health checks as singletons. That's also preferred and recommended by the ASP.NET Core team and the .NET Core team that implemented all of this. So you would register them, and even if the health checks have dependencies, you can register those as singletons as well, and they will be automatically injected. Have a look at all of these samples if you're interested. This is actually enough for now, and let's move on. Okay, so you would bring this into your API, and you have new endpoints which give you an indication of health. So that's one point tackled. But then you will need to think about, how often will I need to check those endpoints, and who will be doing it, from which locations, especially if you have a geo-distributed implementation that's running in multiple locations all over the world. It might be working in one data center but not in the other, so you might have to call those endpoints from different locations as well. And then finally, there's also the alerts. Because if something goes unhealthy for 5 seconds, would you page someone in the middle of the night? Or would you do that only after a couple of minutes of alerts going off? Those are the things you need to get into place and tune and tweak, but at least the information is available now. And there's, for each and every cloud provider, there's tooling out there. I showed you the various products at the beginning, where you can just gather that information and make availability checks on your, so the monitoring on your application. But now you have a formalized endpoint where you can do that. And if things start failing, then you can use the alerting system that usually comes with that. If you find out that all of your sites are suddenly down, or maybe one region is down, then you can take countermeasures. That's one approach. That's the exposed endpoints, which you query by an external monitoring tool. Another way of doing it is using publishers. And with publishers, you would not wait for someone to query your status, but you would push it out periodically. And this is kind of like the metrics approach. You are sending out metrics containing your health information. A lot of options that you can configure for a publisher on timeouts, on periods of execution, but it does pretty much the same thing. You would need to register the health checks in the dependency injection system, giving you the health check service. But as soon as you start registering publishers, you will get the health check publisher hosted service, which is a background service. And that will do the periodic checks for each and every of the publishers that you register. So we have the endpoints registered again, or not, because we wouldn't really be needing that anymore. But as soon as you start registering the additional publishers, and there's a bunch of them from Xaberil, they have the application insights, they have the one for Prometheus and for Datadog. Those three are available, assuming that you would want one, but I'm just showing you what it looks like for App Insights and Prometheus. You would need to configure it just a little bit, and their implementation would be registered with the hosted service and the dependency injection system with the iHealthCheck publisher interface that they implement. They would register it as a mapping in the dependency injection registration system. Once the period of execution gets a new execution moment, the health check publisher will ask the health check service to do its regular health check and give the report. So it will build up the report that we saw earlier, and then it will get that, turn it into metrics that are applicable for the particular publisher. It will get the required services for the registration of our health check publishers that were being built with the code in the left bottom corner. And it will start pushing out the metrics based on the health report to each of those publishers. Now, I'm assuming that most of you will be working on .NET Core 3.0 or 3.1 applications by this time, but there was this period where the .NET Core 2.2 framework had this slight mix-up of registration. I'm just mentioning it here that if you run into this, if any of the background services were already registered, then the one that we saw here, the health check publisher hosted service, would not get registered because they did a slightly wrong way of registering. It's been fixed, just so you know. What I want to show you in the demo is assuming that you have Prometheus and Grafana, to stay away from something that is specific to Microsoft, such as App Insights. Prometheus and Grafana, if you have that, you would have Prometheus. Prometheus would normally not query your endpoints. If you do publishing, you don't have to expose endpoints because you will be pushing it out. So it's actually a little bit more secure as you have a smaller attack surface. We won't be exposing endpoints. Well, we wouldn't need to expose them. Instead, we would register the publisher for Prometheus, and we would also create a push gateway. And a push gateway is a place where the publisher can immediately push out all the metrics, and it doesn't have to wait for Prometheus, which does scraping, and to do an actual scrape of our application, because we would need to expose something. So instead, we will push out health metrics to the push gateway. It will be scraped by Prometheus, just like the other scrape sources that it has. And you can rely on something like Grafana to query Prometheus and get out all the information, and maybe build up some alert that you will send to a notification channel, be that Slack, or maybe if you're doing DevOps, VictorOps, or PagerDuty, so people actually get calls when something is wrong. This is the setup that we will get to in this next demo. For that, I will also switch to Docker Compose setup. So we will stop the running application for now, and we will set this as a startup. Now, inside of this Docker Compose, I will run the application that we had, our web API. I will run that from a container. It's the default Docker file that takes care of building this into a container image, and the Docker Compose file will actually make that into a service hosted from the Docker for desktop tooling. We also have one with the health check UI, but now not inside of our application, but hosted as an additional container. We have a container for Prometheus, where there's a definition file, a YAML file that says what the scrape sources are. And one of those scrape sources is the push gateway that is running on port 1991, which is the default. Prometheus itself is available on 1990. The health check UI is available on port 5000, and we also have Grafana, and Grafana is available on port 3000. So that's our dashboard tooling. And all of that will be running from containers. So by starting up this composition, we will actually run everything from Docker containers. And one important thing is that in the Compose override, I've switched the ASP.NET Core environment to production. And that has an additional effect, because inside of the program CS, I've used this code, web builder, use startup, but I'm using the simple name of the assembly that this code is part of. Doing this switches to convention-based startup. And the convention is that if you are running in a certain environment, in this case production, it will not look first for this method here called configure services, but it will actually try to find a configure production services. And the same goes for the configure that we had here, that it will also try to find a configure production. And now, since there's the current environment matches this name configure plus an environment name, it will use this instead of the one that we had before. And as you can see here, we're registering different endpoints. So there's this health/ready, health/lively, which we'll use in a bit. And this is exposed as an endpoint from a management port. So it's from any available location or host name, but it will use the management port. And the management port are in app settings. If I, let me see, those are available here as an environment variable. The management port is 8080. But the Docker Compose itself doesn't actually expose that to the outside world. And the only thing we're exposing is our HTTP endpoint inside of the container image or container instance, and we expose it as this port on the outside. So this management port is only available from within the Docker environment and not from the outside, which is pretty secure. And we'll get to this in a bit with if we start running from Kubernetes. We've already started this. So if we go to this place here and we go to our implementation, we can actually see it running as it did before. But now we can see that our environment is completely healthy. I've run this is running from the 5000 port, as we saw in the container. That's how it is exposed. And we see that everything is being healthy at the moment. And if we now go to this endpoint, which will set one of the health checks to degrade it, we should see in a couple of seconds that the circuit breakers and the tripwire are going into degraded. And if I do this again, like so, then it should switch the tripwire one to unhealthy in a second. And there we go. Now we can also see this from Prometheus, because it will be pushed out as metrics. And if we execute this graph, you can see that here we were still being healthy a couple of moments ago. And if we execute it again, we should be able to see that we're actually now going back to degraded for the one that is for the circuit breakers health check, and this is the tripwire health check that is now becoming unhealthy. Inside of this this thing here, let me get this out of the way for a second. You can also see that we were healthy for a bit. This is Grafana. Grafana shows some dashboarding, so it has nice visuals, but it also has this notion of alerts. So in this case, we are being healthy at this point. Here we started calling it the first time, the second time, and then you see that it started to go in a tripped or a triggered state. And then after a certain period, it actually said, okay, we're no longer healthy and we're unhealthy now. And I've hooked this up to a Slack channel for notification. As soon as it starts to go unhealthy, it should report it to Slack. And if we are lucky, then let's see, here we go. This should be right from right now that this is a new message coming in that we are actually not healthy anymore, with a nice little screenshot of what we just saw as well. And this is a live view, so you can actually see from Slack or VictorOps or any of the notifications channels that you have that you're not doing so well at the moment. All right, so this is what you get if you start using publishers. The registration of the publishers, we skipped over that at the beginning, but this is the registration. It was in the slides, and you can use various options to do something with the period and the timeouts that you would have for publication. So it's all tweakable. If you have all of this in place, then you're actually in a pretty good place. For cloud applications, you could have resiliency with cloud patterns. For example, you could use the circuit breaker and retries and maybe timeouts and fallback patterns, because that should be in place. One of the samples that I have in the health checks is a health check that checks the circuit breakers, because if circuit breakers start flipping because your code is struggling, circuit breakers going to the open state might actually also be a sign that your application is really, really struggling, and you might call it degraded or even unhealthy. You have the performance metrics, because the health might be part of metrics and instrumentation that also is good to gauge your performance. You will get information that is usable for availability. And that's actually the last part, where we'll look at liveliness and readiness and zero downtime upgrades. But all in all, if you start monitoring each of those aspects, your endpoints, maybe combined with alerts like we just saw in Prometheus and Grafana, you are actually leveraging all the health information that you are pushing out from your system by endpoints or by publishing, and you can take things that you can do. Okay, so let's put this all into practice again. We have 2 endpoints in the setup that we have at the moment. One endpoint for readiness and one for liveliness. And inside of container orchestrators, it's actually very good for the orchestrator to know what the health of the containers is. And if your application is publishing that information through those endpoints, it can monitor those endpoints. And if you yourself, in running in a container, indicate I'm not healthy, Kubernetes might terminate the container and start up a new one, so everything stays nice and healthy. There's 2 configurations that you can give to Kubernetes in particular, the readiness probe and the liveliness probe. You specify the particular path, and here we have chosen for health/ready and health/lively. With a particular port, we had the management port 8080, and it's all internal inside of the cluster, not exposed, so pretty secure. And then you can say, okay, how long should we wait before we start probing for readiness? And readiness means your application is ready to receive traffic from the load balancer inside of the cluster. If it's not ready, it won't get any traffic, and it's just waiting there until it's ready. And it knows, the Kubernetes knows when it's ready, when your endpoint starts giving out 200 OKs. And the liveness probe is for after it's been ready, it's got the traffic, and it indicates if you are still healthy enough and lively. If you're not indicating that, then you will be terminated as a container or as a pod. For that, for those two different endpoints, one of the things that we didn't discuss yet, but you can register multiple checks, but you can tag them while registering with a certain string that might be a filter later on to specify for which endpoints which checks will be executed. And the code is something like this. So you register a check with the tags as a string array, and later on you can give a predicate where you say, okay, if the registration for my health check contains some tag or a combination of tags or starts with, then it should be executed. So in this case, the ready endpoint only executes health checks that have been tagged with ready. And similarly, you can do lively, or just assume that for lively, all health checks will be executed. And that would be where you would say the predicate just says, okay, true, execute all of them. All of them are valid. Order of registration matters if you map the endpoints and the health checks. So keep that in mind. And then for the final part, this is the demo that I want to show you. If you have everything we've discussed so far and you have that, and you want to do a rolling update, a update without with zero downtime, then Kubernetes has this for you there. And if you provide it with the health information, it can actually do that. Assuming that you specify 3 replicas, that means that you have your pod running as version 1, and there's 3 replicas of those running, because you want to make sure that there's, if one of them crashes, there's at least 2 left that take over the load. And those would be placed on various machines inside of the container cluster. We specify that if we upgrade these pods with containers running in them, we want to do a rolling update. And during an update, we say that there can never be more any of those 3 replicas unavailable. So we say 0 unavailable. There should always be at least 3 of those replicas. And while we're replacing them, we can only have an additional 2 new pods running while the old ones go away. This is for 3 replicas. You might say it's not too bad to start with 3 new ones straight away, but if you have 100 pods running and you want to do a rolling update, you might not want to have 100 new ones running side by side with the original 100, which gives you 200 of those things. So the surge is how much there can be extra. So now we will say only up to 5 will be available. All of these are healthy, they're running, and the pod with version 2 is being deployed. And initially, it indicates that it's not ready yet. The ready endpoint says, okay, I'm not ready to start receiving any traffic, but we could search with 2, so we'll start another one. That's what the orchestrator will do. And we have 2 of them running. Now, once either of those gives a green, so it indicates that it's healthy, where the orchestrator can take out one of the original ones, but because now we still have 3 replicas running that are healthy. We can search up to 5 in total, so immediately it will start up a new V2 version, because we need to replace 2 more. And once any of those or all of those indicates that they're ready to receive traffic, we take out the last 2, and then we have 3 new versions without any of the original 3. Well, actually, with that there's still at any point in time 3 of those pods running, and then we have done a 0 downtime deployment with a rolling update. So the new ones need to be up and running before the original ones will be taken away, and this is a way for you to do roll forward upgrades. So never roll back to a previous one, but always move forward. Let's go for the final demo. I have inside of a local Kubernetes cluster, I have the deployment running. That is exactly what we looked at in the slide. So there's in the namespace for monitoring demo, there's 3 replicas running for the web API, and everything is being healthy at the moment. It's currently Retro Gaming Web API v1, and as you can see here inside of the list of images, I have a v1 and a v2 version of the web API. Now, the definition file for the Kubernetes deployment contains the definition for v1, and it has the readiness probe and the liveness probe, just as we saw in the slides. So the 2 endpoints indicate readiness and liveliness. Now, if we change this to be version 2, save that, go here, and then apply that new file, it has a new configuration, so we will start changing. And if we look at the pods, you can see that there's actually something happening there. The 2 new pods are being started. And we can also see that happening inside of our thing here, that there's now 2 replica sets running, the old one and the new one. And the new one is starting up, and the new v2 versions are being deployed. So you can see the ones that are only 28 seconds old, but they are not ready yet. So they're still waiting. And once those, so this is the 3 original ones and the 2 new ones, but the 2 new ones are not healthy yet, because it has a slow startup for demo purposes. After a while, it will indicate that it's ready, and the cluster will see that, and it will find out, okay, so the new ones are ready, and I can take out old ones. This takes a little bit of time, because the new version starting will not be immediate, but we should see this happening. See that there's now actually something changing, something happening, and more is becoming healthy. And as soon as things are back to normal, you can see that things are being terminated as well. So it's terminating now. Now there's 3 new versions that are running, and there's still 1 old version remaining, but that's also being terminated now. We should see that happening here, that it's still being terminated. And once that last one goes away, the old replica set can go away, and the new replica set will become healthy as well. So that should take just a little bit of time. And then finally, our deployment is healthy as a whole again, but we never lost any of the 3 running replicas of our container deployments. And we did a rolling upgrade of all of the containers to a new version. So this should be ready any moment now and turn completely healthy. And see, there we go. Well, that concludes our demos so far. I will skip a bit over the securing part, because we've already covered it, that the management port that keeps away the endpoints and makes it only internal into the cluster. But there is a little bit of code fragment where you can do mapping to your health endpoints only for authenticated users. And if you want to be completely secure, think about the publishing instead of exposing endpoints. You should do an assumption of degraded state, not make your checks too complicated, and have short timeouts, because you don't want the health checks to bog down your system and actually becoming the problem for the health of the service. So what we saw in the past 45 to 50 minutes is that we can instrument our .NET Core application with additional endpoints for health information, where you can use monitoring tooling to get information and build up reports, investigate and alert. You can push it out with publishers as well. And both of those things can be used inside of a container cluster as well, because you can use that for liveliness and health readiness probes. Kubernetes is a good example of an orchestrator that can do that for you. If you have any questions, feel free to join during the Zoom Q&A session that will be around lunchtime. If you want to contact me and have questions, you can use the Twitter or my email address to send me any questions if you can't make it to the Q&A session. Thanks very much for your attention. Have a lovely conference. And for your reference, there's a lot of materials available on the internet, and also a link to the source code that I showed you, so you can check out everything that I showed you in a very quick pace at your own pace. Thanks very much, and hope to see you during the Q&A session. Bye-bye.